Right, so this unit, the first part of it is all about rates of reaction. Whenever you're measuring rates of reaction, it's all about seeing either how quickly something is formed or how quickly something disappears or reacts in a reaction. So the first reaction we're going to look at is that between hydrochloric acid and magnesium. You add a piece of magnesium to some hydrochloric acid, you can see really quickly the magnesium starts to bubble as hydrogen gas is produced. So in this reaction, what you can do is you can measure things like the time it takes for the acid to completely react with the magnesium. That's one way. You can do things like measure the temperature, and you can also measure the amount of gas produced. All of these are perfectly acceptable. The best way to do it is to make sure that it's something that's easily compared. So in this one, I'm going to look at the time or the temperature rise when the magnesium is added to the acid. So the same piece of magnesium to the same piece of acid. Firstly, before I do that, I'm just going to check the temperature of the acid there, and it's at 22 degrees. And then by adding in the magnesium, I can monitor the increase in temperature, because this is a type of reaction called an exothermic reaction. As I said, I can also record time. So usually when we record time, it's time to do something. In this case, I'm going to look at the time to produce a certain amount of gas, or a test tube full of gas. Or I will be if I can get my tube under there. So similar experiment, add the magnesium to the acid, put the tube in, start the timer, and you can see the hydrogen gas being collected here. And you'll stop the timer again when it's completely full of gas. Right now, there's one tube of hydrogen. This is nearly finished reacting. You can see that the temperature here has risen to currently it's about 46 degrees. And as I said, all of these are acceptable ways of measuring the rate. It's all to do with basically some way that you can numerically compare different reactions that are happening. This is another reaction that produces a gas. Reactions that produce gases are quite easy because obviously you can measure the gases that is being produced. These are marble chips or calcium carbonate. When you add this to acid, carbon dioxide gas is produced. So if I add that in there and put that in, and I can do exactly the same method as I did before with hydrogen, collecting the amount of carbon dioxide gas that's produced. This isn't measuring an amount of carbon dioxide gas, it's a really straightforward, simple comparison of the amount of time to produce a certain amount. So it is doing a measurement, but it's a simple version of a measurement technique. This method of recording data from the same experiment is slightly more sophisticated. This piece of equipment here is called the gas syringe, and it allows you to actually measure the volume of the gas that's being produced. So rather than just saying the amount of time it takes to produce a gas, you can now say how quickly that gas is being made. So if I add some more calcium carbonate, some marble chips to my acid, add in the bung and start the timer, I can actually measure after a certain period of time how much gas is being produced. So after 10 seconds, I have 12 mils of gas. After 20 seconds, I can look at it again and see what the measurement will be. And this time it's 20 mils of gas. And that can continue right the way up until I've produced 100 mils of gas. This allows me to see the rate. So at 30 I've got 30 mils of gas. It isn't always a 1-to-1 ratio. This allows me to see how quickly the gas is being produced and look at the rate of gas formation and look at how that rate changes as the reaction changes, as it progresses through all the stages of reaction. Right, both the reactions that we've looked at so far are pretty good because they both produce gases, but a lot of reactions don't produce gases, and somehow you have to try and measure the rate of those reactions as well. This is very concentrated sulfuric acid, and when you add water to concentrated sulfuric acid, it gives out a lot of heat. Now if we measure the rate of temperature change, we can measure the rate of that reaction. Just to illustrate how much heat is given out in this reaction, I'm just going to put a drop of water in there. Now the reaction, when I add 1 drop, has gone up by 2 degrees, which you might not think is a very significant amount, but it has raised quite significantly. Now what I'm going to add here is just about 1 ml of water and record the time taken for the temperature to rise, and hopefully I should be able to show that I would be able to measure a decent temperature rise. If I start at the same time and record the temperature every 5 seconds, then the temperature's gone up by 1 degree in the first 5 seconds. In the second 5 it's gone up by 3. It's now at 48 degrees, and the temperature continues to rise up to 53. And this is just another way. You can't see anything being produced in this reaction. There's no sign of any gas being produced. There's no visible change at all. However, it is significantly hotter just by adding water. So we can measure things. We can measure production of energy. We can measure change of colour. We can measure production of gas. Anything, when you do a rate of reaction, it's either about measuring something being made or something being lost.